In science, we don't use the units that we use in our everyday lives, like inches or pounds or miles, for example. We use metric system units. The metric system is also known as the International System of Units. We also call these SI units. SI. These are going to be based on multiples of 10, which makes it a lot easier to convert from one to another. We use base units in this system. So for mass, we use grams, and we abbreviate that with a lowercase g. For distance or length, we use meters. Volume, we use liters. Time, we use seconds. And temperature, we can either use degrees Celsius or Kelvin. From the base units, we get what we call derived units. We get these units from the base units. So, for example, if I'm figuring out the area of something, I take its length times its width. Well, length is measured in meters. So I would have meters times meters, which gives you meters squared. So all of these come from a combination of my base units. In front of the base unit, I can put a prefix. That's going to tell me which multiple of 10 I need to use. So if I look at this chart, this gives me some common examples of prefixes used in the metric system. Notice that in the middle, I have base units like I had on the previous slide. So this would just be 1 gram, or 1 meter, or 1 liter, etc. Above that, I have units that would indicate that I'm using something larger than a base unit. And below it, I have prefixes that indicate I'm using something smaller than the base unit. So let me show you how this chart works. First, it's telling you the prefix. So we'll start up here with mega. Mega would be the prefix that I would put in front of gram, meter, or liter. So if I have a megagram, first of all, I use a capital M to represent mega. And that means that I would have 1,000,000 base units, so I would have 1,000,000 grams to equal just 1 megagram. That's why there are blanks here. Any of these base units could go into these spaces. And any of those base units can go where it says BU. BU is for base unit. On the opposite end of the spectrum, I have micro, which is represented by a Greek symbol called mu. If I have just 1 gram, that is equal to 1,000,000 micrograms. So very, very, very small units up to very, very large units. So there will be times when I need to convert from grams to kilograms, or from hectometers to meters. And you've probably done this before, but the way you've done it is different than the way we're going to do it this year in physical science. We are not going to just move the decimal point. We're going to use a different method, and it requires us to use conversion factors. A conversion factor is a fraction where the top and the bottom are equivalent, or they're equal to each other. So let me give you an example of that. For my first example, I'm going to convert 250 milligrams to grams. So my first step is to write the original measurement. So my original measurement was 250 milligrams, and I've written it here. My second step is to set up that conversion factor that I discussed above. Then I'm going to cancel the units to make sure that I have the required unit. The required unit for this example is grams, because I want my answer to be in grams. And then lastly, I'm going to multiply across the top and divide by the bottom. So I've first written what my original measurement was. For my conversion factor to help me out, I need to write the unit that I want to get rid of on the bottom. Because if I have the same unit on the top and the bottom, then they cancel. So I would want to put milligrams on the bottom of that conversion factor. Because I'm going from milligrams to grams, that means the unit of grams will be on the top. Now I have to think about what numbers go in front of these units. So I have to think about how I can make these equal. So the easiest thing to do is to think about which one is larger, a gram or a milligram. A gram is larger, so that means in 1 gram, I will have a certain number of milligrams, and that number is 1,000. I know that from the chart that I had on the previous slide. So I set up my conversion factor, that's done. Now I'm going to cancel my units. So milligrams on the top, milligrams on the bottom, those cancel. The only unit that's not crossed out is grams, which is good because that's what I want for my answer. So now I'm going to multiply across the top and divide by the bottom. 250 times 1 is just 250, and that would be grams. And I divide it by anything on the bottom. The only thing on the bottom is 1,000. So now I do 250 divided by 1,000 in my head or in my calculator, and I come up with 0.250 grams. And then I circle my answer. These problems must be completed using this conversion factor. Moving the decimal point is not going to get you all of the available points. This is an important skill we need to have. At this point, I would like you to try to do example 2 and example 3 on your own, pausing the video. And then, once you're done with those, start the video again to check your answers. When you check your answers, make sure that your answer is not only correct, but that your work is also correct. If it is not, then you'll need to watch the rest of the video so that you can see how it should be done. Okay, example 2. Convert 130 meters to centimeters. I rewrote my original measurement. I multiplied it by a conversion factor. I made sure that the unit on the bottom was meters so that they would eventually cancel. The unit on the top is centimeters because that's the unit that I'm trying to get to. Then I had to think about which one is larger. A meter is larger than a centimeter. So in just 1 meter, there are 100 centimeters. I cancel the units and I see I'm left in centimeters. That's what I want to be in. So I multiply what's on the top and divide it by what's on the bottom, and I get 13,000 centimeters. So 130 meters is the same as 13,000 centimeters. Example 3. Convert 6,346 centimeters to meters. I rewrote my original measurement and I multiplied it by a conversion factor. I made sure that centimeters were on the bottom so that they would cancel. Meters is on the top. 6,346 times 1, 6,346. Divided by whatever's on the bottom, which is 100. So I divide those two to get 63.46 meters. Notice that in both of these, the conversion factor is relating centimeters to meters. In this case, I have 100 centimeters over 1 meter. But in this case, I have 1 meter over 100 centimeters. Whatever type of problem you have, that's going to dictate which conversion factor you'll need to use. So, my last example, or not my last example, a more difficult example. I'm going to convert 670 milliliters to kiloliters. Notice that I'm going from a prefix to another prefix. This is what makes it more difficult. The steps are still the same, but there's just an extra step, which doesn't really make sense, but I'll explain. So, first, I need to rewrite the original measurement, just like before. Second, I'm going to set up my conversion factor, cancel my units, just like before. But when I do that, so 670 milliliters times my conversion factor, milliliters goes on the bottom, liters goes on the top, because it's kind of difficult to remember how many milliliters there are in a kiloliter, for example. But you probably know how many milliliters are in 1 liter. So that's our first conversion factor. But when I do that and I cancel my milliliters, then I'm just left in liters. That's not what I need for my answer. So I'm going to set up another conversion factor to convert liters to kiloliters, because kiloliters is what I need my answer to be. So, I'm going to set up a second conversion factor. Liters goes on the bottom, because that's what I want to get rid of. Kiloliters goes on the top, because that's what I want my answer to be in. So I'm going to multiply across the top. 670 times 1 times 1 gives me 670 kiloliters, because that's the only unit left. Divide by the bottom. 1,000 times 1,000 is 1 million. So 670 divided by 1 million gives me 0.0067 kilograms. Kiloliters. Here's a similar example where I'm going from a prefix to a prefix. If you're going from a prefix to a prefix, you will need two conversion factors. So in this case, I would go from hectometers to meters, and then meters to decimeters. 2 steps, 2 conversion factors. Try it on your own, and then check your answer. So how did you do? Convert 560 hectometers to decimeters. Rewrite the original measurement. Multiply by a conversion factor. So I have hectometers on the bottom, so they cancel, and I'm going to meters first. Then I'm going to write meters on the bottom of my second conversion factor, decimeters on the top. So 560 times 10 times 10 divided by 1 is 56,000 decimeters. My last example shows you an example where moving the decimal point would not get you the correct answer. So if I know that 1 inch is equal to 2.54 centimeters, I need to convert 260 inches to meters. First step, write your original measurement, 260 inches. I'm going to convert inches to centimeters. Inches goes on the bottom, so they cancel. Centimeters goes on the top. I know that 1 inch is equal to 2.54 centimeters because the problem told me that they are equal. Then, that would just get me centimeters though. The problem wants me to change it to meters.
Brian Fox, here in the building. Can you please come to the main office? Brian Fox.
So I need to multiply across the top, 260 times 254, and then divide it by 100, which gives me 660.4 divided by 100, which gives me 6.604 meters as my final answer. Again, 260 is what I started with. 6.604 is what I'm ending with. Moving a decimal point would not have worked in this particular situation.